Hi, welcome to Visual Studio Toolbox. I'm your host, Robert Green, and joining me today is Steve Dower. Hey, Steve.
Hi, Rob. How's it going?
Good. Steve's on the Python tools for Visual Studio team and is here to show us the excellent Python tools for Visual Studio. Now, we've done a couple versions, or at least one other version of the Python tools. So this is an update or a new version.
We're just about to release version 2.1.
Okay.
And so this has had a whole lot of updates from the last time we showed it off on Channel 9. So a lot of new things to show.
So Python, obviously a very popular language, a lot of people using it. We're going to touch a little bit in this episode on why people not using it might want to look at it. But we're primarily going to focus on why we think people who are currently doing Python or are going to be doing Python should be using Visual Studio.
Absolutely. Thanks, Rob. So the first thing I'd like to show is what Python developers are currently using, what they're working with. So this is Vim. This is one of the more popular editors that people are using for Python, especially among professional programmers. It's a basic text editor. It's cross-platform. It shows up on Mac, Linux, and Windows as well, which is part of the reason it's popular. But it's a fairly simple text editor with an amazing plugin ecosystem. So you can see we have some syntax highlighting here for Python. I have some basic go-to-definition support through plugins. There's plugins for debugging, there's plugins for completions. But at its heart, it's a simple text editor with not a huge range of functionality. Idle is something that ships with Python. It's a basic editor. It has simple syntax highlighting. One of the cool things about Idle, though, is it has this split editor interactive. So Python is a very interactive language. You don't get anything out of Python until you're actually running the code. There's no compile step. You start running the code and you start getting results. So I hit F5 to run this code, and it actually goes and executes over in this shell. And now I have everything that I just declared. So my class is suddenly there. I can get completions for that. I get help for this where the code is actually running. But I don't get most of that in the editor. So I can get this with my code running when it's actually executing and doing stuff. But that's not the normal editor experience. And debugging is another area where the standard sort of Python approach is lacking. People often go for logging modules or print statements, and Python itself ships with PDB, which is a very simple command-based debugger. I have it here, import PDB, that's bringing in the debugger, and setTrace is going to start it. So now I'm in debugger mode, and I can set a breakpoint on a function, and then when I call that function, it's going to break in again, and I can have a look at where we are in context, take a couple of steps. I can look at variables that are in the current scope, and that's about the extent of what Python's debugging support looks like for most users, and especially the professional users.
So there's nice stuff in there, but obviously if you are using Visual Studio, we think you get more.
You get a lot more from Visual Studio. So let me show you the start of our support here. The first thing you'll see is it's very colorful. The colors are a new feature. We will detect and highlight modules a different color everywhere they're used. Classes show up as a different color. You noticed that before.
There's squigglies, which I don't think the other two editors were giving you.
Yep, we'll give you squigglies and tell you, oh hey, you imported something that we don't know about. This is probably a mistake. You might want to have a look. And we do type inference the whole way through. Python is a dynamically typed language, so all the variables here don't have types attached to them. It's all under value, which makes it hard for an editor to be able to tell you what type this is. So we do some complicated analysis and flow everything through. So this function call here is passing 10, which we know is an integer. This call comes through here, and because we've seen the call, we can see the parameter is an int, which means if you dot through, we can show you the members of int, and so you can have that assistance to make the call you want. And we do this on the fly, so as soon as I make a change, and now we're calling the same function with a float, we have both types here. In Python, this is completely legitimate. It won't happen at the same time, but sometimes when this function's called, you'll get a float, sometimes you'll get an int, and the code has to be able to handle both of those. So now when we dot through, we'll show you all of the members involved. If you get a float, you can use any of the ones marked float. If it's an int, you can use these ones. If you want to be safe, then you use image or conjugate, because that's on both. And so you're always going to be able to use that when the function call comes through. So I mentioned the dynamic typing. This is one of the really cool features about Python. What it means is that when you're coding Python, you never have to specify the type. You don't have to tell Python about your code. You let Python figure out what it can about your code and run it the way that you're trying to use it. And what this really means, as far as it being a maintainable language and being an adaptable language, is a library author can't lock you out. If they put the wrong type on a function, or if they want to change their signature, you don't have to follow their rules or their intent. You get to make your own. So here's a simple example. I have this function, translate words. It's going to take a string, some text, and a dictionary. And we'll split the text up into words and run it through the dictionary and translate some of them. So let me grab this, because you have to run the code before it exists. And here's a quick sample. This is a dictionary literal. You can actually see we know it's addictive strings. And by running this and passing this dictionary into the function, it will run the code, and we can see it's gone through, it's grabbed fall and replaced it with tumble, because that's what's in the dictionary. Tumbling has become falling. Now, if this had been written in C# or something similar, then that function would say, give me a dictionary, and you couldn't give it something else. But this is Python. So all we really need to give it is something that this indexing operator can work on. So what I have here is a small class. There's no subclassing or anything going on. There's no interfaces, just an arbitrary class, and we've defined getItem. This is overloading that operator, and it's going to take the key and return it uppercased if it has a T in it, otherwise the normal one. And the function call looks exactly the same. I'm passing an instance of this class into the function that expects a dictionary. And we can see when I run this and the print statement, it's taken the words with T in them and replaced them with uppercase. So we no longer have a dictionary like it expected, but the function still works. I can step this up again. Here I have a more complicated class that's actually going to go off and use the Bing Translation API. And so now, instead of a dictionary, I'll start this running because it can take a little bit of time. Now, instead of a dictionary, we have a web service. And the code that originally planned for a dictionary is now speaking to a web service, and it doesn't know. And the original author didn't realize that that might happen.
Right.
And you can see we have a pretty poor translation into German of most of the words. But we can reuse it as well. So I can make an instance of this class and pass the entire text all at once. And that should get us a much better translation. Except I don't know German, so it might not be.
I assume it's right.
I hope so. Bing says so. So that's a great reason that people should be using Python. Traditionally, switching to Python has meant giving up Visual Studio, and that's not a concession that most of us really want to make.
Right.
And I mean, you saw the debugging example before. Who wants to switch to a debugger like that, when previously you've been able to just go over here, set a breakpoint, hit F5, and your code starts running, and as soon as it gets up to that breakpoint, you're inside Visual Studio. You have all of your local variables. You can hover over the members, see what their values are. You can step, and so we've brought this into Visual Studio for Python.
I imagine that people who have used Visual Studio are looking at this going, oh, you can set breakpoints. Okay, it's Visual Studio. But people who are writing in Python that aren't using Visual Studio would look at this and go, what?
I don't have to write print statements anymore? When I'm demoing this stuff for Python developers, I've normally stopped by now. They're already blown away.
Sign me up.
Yeah,
at least let me go get do Python tools work with Express?
Python tools do work with Express.
Awesome.
If you've got the latest updates and you get the latest version of Python tools, then we will work with Express for web and Express for desktop.
Cool. So people who are using Python can try this out for free, and then when they decide they love Visual Studio, we hope they, of course, will give us a little bit of money.
Absolutely. There's absolutely no need to give us any money to be developing Python on Windows.
Is there any functionality you don't get? Editor, debugger, features?
The editor is there. The editor is one of the best in the field at the moment. We have people tell us that all the time. They love what the editor can do. The debugger blows people away, and most of the features are there. You get conditional breakpoints, trace points. Locals are there. I have another cool debugger feature coming up later, which will blow you away.
The ability to do source code control with
source control is all there in Visual Studio, or Git.
Yep.
You can
Or Git,
use it
of
with
course.
Git now, or any plugin that goes into Visual Studio.
Yep.
So you get most of the benefits of Visual Studio for free simply by being inside Visual Studio.
Right.
Which is great. Another thing that a lot of Python developers want to be able to do is profiling. I don't know what just happened there. You can go away. Is profiling. Python comes with a profiler. This is its output. It's functional, all the information you need's there, but we can run profiling inside Visual Studio now and give you a Visual Studio report. And so you get the hot path, you can click through into these, you can see callers, callees, it will link back up to the source code. It's that interactive experience that Visual Studio gives people that developers love because it just makes them so much more productive, and we're bringing that to Python developers. But I know a lot of Visual Studio devs love NuGet, and they can't stand to be separated from NuGet. So Python has an equivalent. It's called the Python Package Index, and about the only difference is it has twice as many packages.
Oh, okay.
All of these are freely available, and there's a huge range of data, science, geometry, biology, astronomy, physics, mathematics packages. A lot of the latest research gets published first in Python. There's a lot of PhD theses come full of Python code. Brand new research is written in Python, released in Python first. And so if you want to do science of any sort inside Visual Studio, it's been possible before, but once you have Python, it's so easy.
Right. Cool.
But what if you really, really like .NET? And that's okay. That's okay. There's an alternative implementation of Python that a lot of people have heard of. It's called IronPython, that's based in .NET. So it's running on the CLR, and it gives you full access to everything that .NET normally gives you. So I can import from system. If you program in .NET, you'll recognize these namespaces. And I can import again. I can import anything I want out of the .NET namespaces and use it. Now, this is great for automation and testing. We use IronPython for a lot of our automated tests because you can just call straight into .NET for a lot of things. And it's also handy if you just really quickly want to check out how an API works. So let's say, for example, you want to find out if file, I'll grab path as well. You want to see if file.exists throws an exception when you give it an invalid path. You know, off the top of your head?
I thought it was a silent fail. I thought it didn't.
Let's have a look. There's an invalid path. Let's see what it does. Nope, it just fails. How nice. What about if we check the same thing with path get directory name? Any guesses?
Well, for consistent, well, because that's not a true false, that I would expect that to blow up.
And it does.
Hey, I'm 2 for 2.
So it's an easy way to check what error handling you need in your C# code without having to go digging through documentation. And these are easy, well-documented cases. Plenty of APIs that don't have the documentation for this.
Right.
It's a really easy way to check. Here's another one. File.exists. What if I pass null?
Ooh.
Which is spelt none. Null reference exception?
I'm going to say it blows up.
Blows up. Oh, there you go. File exists, doesn't need any protection at all. Give it whatever you want, and it's not going to blow up on you. And here's another thing. I've been using this without mentioning anything. Visual Studio doesn't normally have interactive development like this.
Right.
This is a very Pythonic feature. Python has had this from the start, and we've brought it into Visual Studio. So this is great for quickly trying some code, as we just did, tweaking a function and retrying it over and over again, feeding in different inputs to see what outputs are getting. And we brought this into Visual Studio. So now you can do this inside Visual Studio. You don't have to switch out.
That is kind of cool. It's a lot easier than what many people do when they're just playing around with APIs. Just create a WinForm map, slap a button on it,
Absolutely.
and then when you click the button, you run some code, which is pretty straightforward and easy to do, but there's a lot of overhead to just play around.
There's a compile step, you want
Yeah.
to change it, and then you've got to recompile and rerun. It's not quite as simple as having this interactive experience right there. And this is integrated through our Python project system as well. So if you've got a Python project with lots of code, you can get to all of that through the interactive window. And it's a really great development experience. So, Azure. Hey, can we do a talk these days without mentioning Azure? I don't think we can.
It's not in my contract.
So our team has gone out and worked with a whole lot of the Azure teams, Azure tools, Azure websites, and we've integrated support the whole way through. We've come up with a client libraries for Azure that provide Python APIs for Service Bus and the storage APIs. We have publishing to websites, so you can right-click a Python project and choose to publish to websites. Same thing for cloud service. And we also have it integrated into Solution Explorer. If you have a Python website, you can right-click and attach a debugger to remotely debug your Python website from your local machine.
Cool.
And we actually have remote debugging as a separate feature that will connect to any platform. And if you want to remotely debug Python code running on Linux or running on Mac, you can do that as well. You get the full debugging experience inside Visual Studio while the code is running on a completely different platform.
Yep. Excellent.
And here's the big one. This is getting people really excited. A lot of Python developers will write code in C. The most common Python interpreter that's used is written in C. You can write modules for it in C, which will be faster, they'll perform better, closer integration with the platform. A lot of good reasons to do it. And at this point, Visual Studio with our tools is the only multi-language Python IDE that exists that will let you build, run, and debug mixed Python C++ code. So you can see I have two projects in this solution. One's Python, the other is C++. I can build this, hit F5 and start running it. And we're going to hit this breakpoint here in the Python code. And immediately below this breakpoint, we're calling this fastmap10.8. That function I've written in C because it's faster. And I can step through, and as I step into that, we've now popped up into C code. I can keep stepping, and eventually we come back into Python, we've hit a breakpoint. You can see on the call stack here, we're jumping between Python, C++, Python.
Yep.
At every step, we have all of the information about the Python variables that are there, the C variables, the ones that are actually Python variables. We can represent those as they are in Python, and not just as they are in C. And this is a huge thing for a lot of developers who simply cannot get this experience any other way.
Right. Very, very.
And so that's a nice broad view of Python itself and the support that we have in Visual Studio for it. We all love Python. We think it's a great language. It's really powerful. It has a lot of flexibility for extended support of libraries and packages that you can't get from other languages. You have a stability, you have flexibility to change how you interact with those libraries yourself. You're not dependent on the person who wrote them making changes for you. And it's a great language. It's a great language for the web, a great language for data science. It's a great language for automation. It has so many applications, and we're bringing this into the Microsoft developer family and giving them a lot of tools that they don't have, getting some new ideas, new concepts, new libraries, new support that we don't have from them. We're really excited to be getting Python into such a position.
So where do people go get the Python tools?
So to get the Python tools, you'll go to the site I had open before, pytools.codeplex.com. You can get our tools.
Okay.
You'll also have to go to python.org and get a copy of Python itself.
Yep.
Or you can get distributions. There's distributions called Anaconda or Canopy, Python XY that come with a whole lot of packages pre-set up for you. So if you really just want to get going into data science or something along those lines, I recommend one of those. Get Anaconda, Canopy. I'll get you links so we can put them below the video for people.
Yeah. And so the current tools are in what state? It's a preview.
The current tools are at RC.
RC. Okay.
So yeah, we're going to be shipping 2.1 final. Probably not before this video goes out, but very soon.
Okay. Great. And it requires Visual Studio 2013,
Visual Studio 2010, 2012, or 2013.
Nice.
If you've got professional or later. If you want to use the Express editions, then you'll need 2013.
Okay.
And only web or desktop.
Got it.
So.
Okay. So Express 2013, but Pro or above 10, 12, and 13.
Right.
Sweet. Very nice. And then presumably it will work in the upcoming Dev 14 at some point. Maybe not right now, but
not right away. But
we
we've
get to a more stable
We're
build.
definitely got plans to make that happen.
Sweet, awesome. Cool. So if you are using Python, you've just seen Visual Studio is absolutely the best IDE you should be using. If you have friends, colleagues that are using Python, they should absolutely take a look at Visual Studio. And if you've been wondering about Python and want to start seeing what it can do, best place to learn is
Python.org is a great
Python.org?
starting point.
Okay.
It's got links on the front page, tutorials, overviews, and again, more links to training sites. There's a lot of content out there for Python right now.
Excellent. Thanks for coming on and showing us this.
Thank you.
All right, hope you enjoyed that, and we'll see you next time on Visual Studio Toolbox.